everyone, and welcome to another video. So today I want to talk a little bit about decoding APRS packets. Namely, I want to be able to take a ham radio like this and listen for packets that sound like this, and then getting it decoded on a computer. So if that sounds like fun, let's jump over to the garage and let me show you the source of where I'm broadcasting all these APRS packets from. Alright, so what we're really talking about in this video is transmitting and receiving APRS packets. So let me show you this right here, which is the source, or what is going to be transmitting all of our APRS packets. This is a little payload that we are going to launch on a high altitude weather balloon. So we've got a little science club with the kids where we're putting this thing together, and one of the main systems on board this is, you can see it right over here. I apologize for the mess of wires, but this is basically an Arduino. You can kind of see it over here. I got an Arduino Uno hooked up to a, right here, that is a GPS receiver, right? And the GPS receiver is hooked up to, I don't know if you can see that over there, but that is a Radiometrics HX1 radio transmitter. In fact, here I've got another one. I bought two of them. So here, this is what it is, right? So as you can see, this is a radio transmitter at the 144.39 megahertz frequency, which is the APRS frequency. So what this guy is doing is we are basically trying to get the position of this payload box, and then we are going to do a little bit of processing of that information on the Arduino and then send out an APRS packet over this radio. And then you can actually see we've got a little antenna that we've kind of made here. So actually let me step back. You can kind of see these little four wires are the ground plane, and then this kind of vertical is the main active element. But that should be tuned also for this APRS frequency. So theoretically, this thing right now, I've actually got it powered on, and I think I've dangled, yep, here's the GPS antenna. So this guy is actually aware of its position right now via GPS and is broadcasting that position via APRS packets over 144.39 megahertz. So again, I've got my ham technician's license, so this thing is transmitting out the packets with my call sign and the position information all embedded right now. If you're more interested in building this entire APRS transmission system, I've got a dedicated video for this. So for this video, we don't need to worry about the circuit diagram or what this is doing. All this we care about is this is basically our source of APRS packets, right? This guy here is transmitting out the APRS packets, and actually theoretically is doing it right now. If we could just listen to the APRS frequency of 144.39, we should be able to hear that. So in fact, if we go ahead and grab ourselves, like, you know, here I've got my little, I've got a Baofeng radio, so let's turn it on. It's already tuned to that frequency.
Channel mode.
Do you hear that? I set it up so every 5 seconds it should broadcast a packet. There's another packet. So great. So the payload box over there is transmitting information over that frequency. It's transmitting APRS packets, which this radio here can pick up. And in fact, if I could speak binary or whatever this is, this modem sound is basically has all the information encoded into it, right? So it has the position information, it's got my call sign, it's got whatever else I programmed the Arduino to transmit out. This is being squawked out right now over this frequency. So I guess, like I said, if we could decode this, we could actually get that information. So that's the next step in the process, is how can we decode these packets into something intelligible? All right, so here we are. We've got the radio, and again, the payload is still transmitting APRS packets happily, and as you can hear, it's still receiving them here on the radio. Now, what we need to do is we would like to get that signal into the computer so we can decode it. So there's a couple ways you could do this. One way is, I guess you could turn up the volume of this and hold it near the computer's microphone, right? But that seems like a pretty sketchy way of trying to get the this signal, this audio signal from the radio into the computer. So you know what, let me turn this off so we don't have to keep listening to it squawking. So the packets are still coming in, but this will let us talk a little bit more easily. So what's nice about a lot of these radios, and especially, you know, like this Baofeng, is if you open up the side, there's an interface here for both a external microphone and speaker. So all we need to do is we need to get a cable that will basically bring this audio signal from the radio into the computer, and that is what this guy is used for. So this is the Baofeng B-Tech APRS K1 or K2 cable, depending on where you look. So for example, in fact, let me bring up the listing here. I don't know if you can see that easily on my computer, but this is the cable that I bought. It's a little expensive, surprisingly. You know, this is over $20, $25, something like that, but it's got some nice features in the sense it's got some circuitry in here to allow us to do talking as well, or transmitting as well as receiving. But as you can see, what it's got on one side is it's got an interface that's appropriate to match into the radio. So if we just plug this in, and maybe what I will mention is take a look at this, right? Each of these are a TRS and a TRS. So if you plug this in to the radio like such, okay, then on the other side, you've got a TRRS here. So what this should do is it should hopefully have the audio signal. It should have audio left, audio right, microphone, and a ground in some order. And that's the part that's going to be a little bit interesting, is depending on different manufacturers, that's going to depend which signal, the microphone or whichever left or right speaker, is placed on which one of these, the tip, this ring, or that other ring, or the sleeve, right? So what's actually nice about this cable is, again, maybe we'll just quickly unbox it. I'll show you what comes in the box with the cable. So it's got some information about it. And also, they have what they call this reverse adapter information. And they supply, let me see if I can take it out of the box. Here, they supply this guy, which is basically going to help you reverse the order. So depending on your application, if you're plugging this into like a phone or a computer, it might expect the ordering of the polarity of these tip, ring, sleeve in a different order. And if that's the case, what you can do is you can use this included reverse adapter. Let me just take it out here. And then you can plug in the female side like such, and now you've got it basically in an alternatively reversed order. So hopefully between this configuration or this configuration, you're going to be able to get it interfaced into your computer appropriately. Now, this is getting the signal from the radio to this 3.5 millimeter TRRS jack. Now, depending on your computer, you might have to come up with interesting ways to get it into the computer. So luckily for me, I've got this, this Microsoft Surface laptop, and right here on the side, it does accept a 3.5 millimeter TRRS. Now, again, the ordering of these TRRS is going to come into question, as we'll see in a second. But there are other types of interfaces. For example, let me take this guy off the tripod and I'll show you. Like, let's say you had a something more traditional, like a desktop PC or another laptop, where, like, for example here, you can see this desktop has two separate 3.5 millimeter jacks. So this is a TRS for the headphones, and this again is a TRS for the microphone. So you have two separate inputs. So what you might need to do in that case is get yourself one of these guys. So this is a splitter, right, where it goes in on the female side is a 3.5 millimeter TRRS, and then it breaks it into the let me see if I can get these without flopping around. You can kind of see the labels on there, right? The top one here is the headphone TRS, and the bottom is the microphone TRS. So you can take this and plug it into the appropriate locations, like such and like such, like that on your computer, right? And then you can plug the Baofeng cable into here. So that's another option of how to get it into your computer. And then finally, let me show you a third option. Is something like this. You can get yourself an external converter, which goes from 3.5 millimeter TRSs for both the you can see on this side the headset and this side the microphone, to USB. So that's another way you can get it into your computer. So again, you combine this with this and combine it with the Baofeng cable here, and hopefully, if needed, combine it with the reverse adapter. So again, this is a lot of cables, but hopefully you should be able to get this working. So let's see if we can get this interfaced and going into this Surface laptop using some combination of these. So in our case, we are just going to use the radio, the Baofeng cable, and then we are going to have to see if we need to use the reverse adapter or not, okay? So tell you what, let's jump over to the computer and take a look at the sound card settings. All right, so here we are. So nothing is connected yet. So as you can see, I've got this just attached to the radio, but not plugged into the computer. So the first thing I'm going to do here in the computer is, tell you what, let's open up our sound card settings. So let's go here to the control panel, okay? And then come here to sound. Okay, and now we've got a couple of things that we can look at. Now, in this particular application, all we care about is listening for the packet. So I don't care about actually sending out audio information. I just want to consume that. So in other words, I'm going to come here to this recording tab, and notice right now we've got a couple of different recording devices. So you can see the built-in microphone array is actually picking up my voice talking right now. So hello, 1, 2, testing. So you can see as I talk, the microphone picks it up and you get some sound levels. So again, one option like we talked about earlier is maybe you just hold the radio, the Baofeng radio, close to this microphone, and it will pick it up and it will be able to record it, but that's probably not what we want to do. Instead, what we want is we want this thing, the headset microphone. We want to record in through this. This is going to be a much cleaner signal. So the first thing I'm going to do is, tell you what, let's actually go ahead and maybe change the name of this. So I'm going to right click on this and come here to properties, and let's just change the name from headset microphone just to something a little bit more descriptive, and so we can make note of what it is down the line. So I don't know, let's call this, how about TRRS mic, or maybe let's just call this, how about wired mic input or something like that. Again, just anything. Remember this, this will come into play later. So let's go ahead and say apply. We're just going to change the name of it, okay? So now, here it is, down here, it's called the wired mic input, okay? So at this point, you can see the computer realizes that it's not plugged in. So now, let's go ahead and take the Baofeng TRRS cable and plug it in, okay? All right, and as soon as we plug it in, it should notice that something got plugged. Aha, it noticed that something got plugged in, right? Now, there's no sound coming into it. And as you can see here, from the audio levels, we're getting nothing. And again, that's probably because this radio is off. So let's turn this radio on and turn up the volume, you know, halfway or something like that. Now look at that. Now you see the green light comes on, so we received something. So that's the packets coming in once every 5 seconds, right? And again, you don't see it coming in. So we've got a little bit of an issue here, okay? And what might be interesting to do now is let's go ahead and this is sometimes where it's a little bit helpful. You can tell that when the packets come in, the radio is picking them up and it's sending them out, but you don't hear anything because this speaker has been disabled. So you can't really hear the packets any longer. And again, that's intentional because we want the computer to hear these. So sometimes in this case, it actually might be useful to have a second radio that is not plugged in or wired into the computer. So let me turn this guy on.
Panel mode.
There we go. So we can clearly still hear the packets coming in, right? So both of these radios are receiving the packets, right? But just one of them, it should be routing it to the computer, okay? So let me turn off this one and just keep the one that's routing into the computer. And again, we see we've got an issue because there's no sound levels coming in. So that is where I think we need to take this reverse cable adapter into play. So let me unplug this from the computer. I'm going to plug in the reverse cable adapter, okay? And now replug this into the computer, okay? And now give it a second. Aha! There, that's looking a lot better. In fact, if I turn this up, right, now we're able to see sound coming in. We're seeing the packets come in over this microphone input, right, the wired microphone input. So this is great. In fact, if we want to prove this to ourselves, tell you what, let's fire up a audio recording piece of software like Audacity, which is super helpful. Let me move this over to the side so we can see this all in one shot. Okay, and I will change this microphone or the input array to this guy, right? The wired mic input, that's the one we're looking for. And now let me just hit record. There's a packet. Aha, look at that. There's the packet, right? There it is coming in as an audio waveform. And look at that. Every 5 seconds it comes through. This is looking awesome. So tell you what, let me stop this. And actually, let me turn off the radio. Okay, so the radio is now off. And now we can even come back here and listen to these packets in Audacity that we captured on the computer. So let me play this back. Oh, actually, you know what we should probably do? It's going to play back through this cable. So I'm going to unplug the cable. Right, so the radio is now completely unplugged from the computer, and now this is just going to play back over the speakers of the computer. Oopsies. Oh, sorry, I have this thing set up, hold on, because I have this now. Okay, let's try this. Oh, man. Okay, I think I've got the audio devices set up oddly right now, but I should be able to get this thing to output. Let me try this. Is that guy going to be a good output? There we go. Now we're playing it back. All right, so clearly we're able to now capture these packets on the computer. We just now need to decode these packets because, again, it's nice to have the waveform, but we really want the information. We want the lat long altitude from the GPS that is embedded in this waveform. So that's the next step we need to take. All right, so to decode those audio packets, we are going to use a program called Direwolf. So like any other software nowadays, you just go to Google and type in Direwolf. Although nowadays in this day and age, so we don't get some stuff about Game of Thrones, you might want to type in Direwolf radio or something like that. And here we are. Here, it'll take you to the GitHub webpage for Direwolf. So you could go ahead and clone this repository if you want to build this thing yourself. I don't think I want to build it. I just want to grab some of the pre-compiled versions of this. So to do that, let's come here to the tags, and I'll come here to releases. And I will pick a version that I want. So let's get this latest stable one, version 1.6, okay? So let's go ahead and we just need to download, here it is, Direwolf 1.6, yeah, the x86 and 64. So let's go ahead and download this. And you'll see it's actually really simple. It's a zip file that you're going to get. So if I go ahead and take a look at this, let me just go ahead and unzip this right here. I'm going to extract all of the files. Okay, and then what we end up with is, yeah, this folder, which just has, as you can see, like an exe and a configuration file and a few other things that we're going to use. So what I'm going to do is, you really can just move this anywhere on your machine. It really doesn't matter. This is a kind of an old school program where you're not really going about and installing anything. So let me just go ahead and paste this in my temporary folder. And if you come into here, like I said, here is the actual program Direwolf. Okay, so all we're going to have to do is mess around with basically this file here, direwolf.conf, the configuration file. So before we, well, you know what, it might be worth it to just open this up and take a look at it. Okay, so let me open this thing, and it's over here. Oh, sorry, I've got a bunch of other junk open. Let me close some of these so we can all see this all in one spot. Okay, so here it is. Here's the Direwolf configuration file. As you can see, it's just got a bunch of stuff commented out, but then there's a couple of these things that we are going to have to change in terms of adding different devices for Direwolf to listen to, as well as making a couple of other changes. So the first thing we're going to want to do is figure out which audio channel are we going to be using for listening to decode these packets. So to do that, let me close this configuration file and let's just come here and run direwolf.exe. Okay, so let me do that right now. I'm going to double click that. The first time you run this, you might get a bunch of Windows firewall stuff and all that kind of good stuff. So I'm just going to allow access. Okay. Now, in this case, notice here that available audio input devices, there's only one of them, right? There's only this microphone array. And the reason why is, again, if you come here into your control panel, right, and we look at sound, okay, and we come here to recording, notice that we only have the microphone array enabled right now, right? Remember that the radio is actually unplugged, right? In the last step, we completely unplugged it just for testing purposes, right? So this wired mic input is not available right now, okay? So tell you what, let's go over here to Direwolf. Let's close Direwolf, okay? Now let's plug in our radio, okay? So I'm going to go take the reverse adapter TRRS cable, plug it in. Let's come here and watch that the computer recognizes, aha, there it is. Now we get the wired mic input, okay? So now we've got two audio devices. So now let's come back and run Direwolf. Okay, and now if you look here on the available audio devices, we have two of them. So now there is device 0, which is the wired mic input, and device 1, which is the microphone array. So what we want is we are going to want to tell Direwolf to listen to this one, right? The wired mic input. And again, remember we talked about earlier when you renamed that actual audio channel, I wanted you to make a note of whatever you called it, and you can see whatever you called it shows up right here. So keep in mind, we care about audio receive device number 0. So this is what we care about, okay? So let's go ahead and close this. We'll kill Direwolf, and sometimes it takes a little second once you click X for it to die. And now let's come back to this configuration file, and again, right-click, edit this thing, and we're going to have to make some changes in here. All right, so what we need to do is come into this section where it says, first audio device properties, right? So all we're going to do here is we are going to remove this comment, and now we just saw that it's device number 0. So I'll just delete those 3 and 4 and just add 0, and that should be it to start off with. So let's go ahead and save this, and now close the config file, and now let's reopen Direwolf. Okay, and now look at this. Now it says available audio input devices. Now notice there's a star here over 0. So basically we should be using this. We have selected this to tell Direwolf to start listening over that channel for packets. So where are the packets? Well, as we saw, I think I turned the radio off at some point. So we're gonna have to turn this radio on to start listening for packets. So again, let me move this over to the side. And what we are going to want to see is that, the payload box, the APRS packets are still being sent out and over the air, and then the radio should pick it up. We should now send it out over the cable. The reverse adapter TRS is going to flip the TRRS appropriate so that it gets into the computer. Then it gets to this wired mic input channel, which then hopefully Direwolf is listening to and is ready to decode the packet. So that's the entire workflow. So you know what? Let's give it a try. So let me turn on the radio. And actually, here's an interesting. Oops, sorry, I messed up. Let me turn on the radio. I've turned on the radio, but the volume of the radio is really, really low. Okay, so you can see the radio is receiving the packets, but again, we're not seeing anything on the computer because the volume is just too low, right? And you can see this in the sound bar over here. We're not getting anything. So you may want to just start. Sometimes, if you're having trouble, just increase the volume on your radio. Okay, let's try that again. Okay, this is getting better. So now we're seeing some lines come up. So let's keep increasing the volume. A little more, and then should hopefully start decoding. Let me see. Oops, maybe that's a little too high. Let me back it off a skosh. All right, so I don't really know what the issue was, but I just ended up stopping Direwolf, so I closed the application. So again, let's just double check. Yep, our packets are coming in okay. And yep, it looks like it's coming in on the wired mic input. So I just ended up restarting Direwolf. So let's just restart Direwolf. And now, packet comes in. And look at that, it gets decoded, right? This is pretty awesome. So again, your output might look similar, so you should start seeing some things. I've just kind of blurred this out for privacy's sake, so because it's got my lat long altitude here, but you should basically start seeing these messages getting decoded into Direwolf. So this is totally working. All right, let's close Direwolf, and I want to show you one other thing that you may be interested in. So you might want to save all of these files, right? So what you can end up doing is, again, let's open up the Direwolf configuration file. And it's nice that we've got all these packets coming in, but it would be great if we could actually, log all of that information to the machine. So to do that, all you need to do is in this configuration file, scroll all the way down to the bottom. Okay, and we're just going to add a line, and gosh, I'm trying to remember exactly what it was. Actually, this is why I wrote it down in my other file. Let me open this up, and I'll show you. Yeah, it's one little line here, right? So here is some information. Let me go ahead and I'll just copy all this here from my other saved configuration file and paste it into the bottom of this file. And if you stare at this, or if you want to go to this website, all we're doing is adding one line. It's LOGDIR space period. That is it, right? Logdir in caps space period, okay? So if you save this now, close the configuration file, and now let me come back to the folder we were in. Now when we run Direwolf, again, let me come here to direwolf.exe, run this. As soon as it starts decoding, we should see a file show up. There, aha, look at that. There it is. Here is the file, right? So inside this file, it should be saving all of the information about these packets that it is decoding. So again, let's grab a couple of data points. And again, I'll blur this out for privacy's sake. But again, let me grab, I don't know, 5 points. That seems reasonable. Okay, now let's close Direwolf. And now here in this log file, if you go ahead and take a look at this, again, I've just blurred out certain sections of this for privacy, but you can see it's basically saving all the information about the packets that are coming in. So this is working pretty great. So now that we've got this set up and working, why don't we go ahead and drive around with this payload and see if we can gather data as the APRS transmit system in that Arduino is just basically broadcasting all this information. All right, so here we are out at the local park, and we've got the APRS /HX1 radio system all installed into this little payload box. So again, this is our payload box that we are going to be sending up into the upper atmosphere, hopefully with our high altitude weather balloon, but we can use it for testing just to make sure that the APRS transmission system is working correctly. And again, you can kind of see I've got our 2 Baofeng radios. We've also got the laptop hooked up to the radios via the Baofeng BTEC K1 cable. And we've got Direwolf up and running and decoding the packets as we just discussed. I know it's probably a little bit hard to see with the sun and the glare, but it looks pretty much like what we saw earlier. So now let's go ahead and pick up the payload box with the APRS transmitter system installed and just walk around the park a bit while leaving the receiving station here on the table and see what kind of data we can collect. All right, so here's the Direwolf log file that I've just downloaded and moved to a specific folder on my machine. So let's actually take a look at this. So if I just open this up in Notepad, as we saw earlier, yeah, this is really interesting. It's just got all of our information embedded during our walk around the park. So for example, here's all of our APRS packets right here. What's actually also really neat is, look at this, we also heard other packets right here. So here's someone else's packet, here's somebody else's packet. So you can see our packets are interspersed with other packets that are sharing this 144.39 megahertz frequency. And as you can see, we're collecting lots of data here. And again, I think I mentioned earlier that what's nice about our system is that it is actually embedding other metadata into this APRS message. So not only do we have our call sign and our kind of SSID or identifier here, but we've got lat, long, altitude, and also over here I've got the temperatures from the two sensors, temperature sensor A and temperature sensor B, as well as a measurement of the battery voltage. This is not actually the battery voltage. This is a bit, an integer that's related to the battery voltage that is powering the entire APRS transmit system on the payload box. So again, a lot of information is embedded in all of these packets. And as you can see, we basically get all sorts of APRS traffic that we pick up. Now, what we can do now is probably try to parse some of this data just to see if it's reasonable. So, tell you what, let me close this, and I actually have, I wrote some MATLAB code to basically go ahead and parse all of that. So, let's just go ahead and filter for our particular call sign and ID. So, this is my call sign, my ID. Let me just run my code here, which is going to go through that log file, pull out all of the relevant information, parse all of the comments to get the temperature and the voltage bits and all that stuff. So for example, here it is. This is great. Look, so we can see the speed. So actually, yeah, this is when we were driving into the park. So you can see as we were driving in with the in the car, yeah, we're going about 20 miles an hour, but then we stopped, and then this is probably when we were walking around the park, and then actually we put the payload back inside the car, and I went around and played around the park with the kids for a little bit, so you can see that the speed goes to 0. Now look at the temperature. This is interesting, right? The temperature, as we were driving inside the car was hot, but then we took it outside and we were walking around and the temperature went down. But then when we slammed it back inside the car and shut the door, the temperature shot up to, 90-some degrees. And what else is interesting about this is the voltage is kind of interesting. I actually used a bad LiPo battery, and you can see that the voltage just crashed. Then kind of started coming back up because it was basically on the way to dying. So this actually, the packets shut off because the battery completely died at the end. So this is about, I think, around 2 hours of data. So again, this is the sort of the metadata that is embedded in those APRS packets. What we probably care about more is the actual position information. So let's pull that out. And as you can see here, I've plotted it and parsed it, and as you can see, this looks totally reasonable. As you can see, we're driving into the park along the road, and here is where I think we kind of parked the car, and then we were walking around in this loop around the park, and as you can see, yeah, this looks completely reasonable, right? So this is great. So it looks like this system is totally working. And actually, what's even more interesting is maybe what we should do is remember that this log file, it had all kinds of other packets as well. Not just our packets for us here, but all of these other packets, here's somebody, here's another one. So you know what? Tell you what, let's not filter these results. Let's actually look at all of the data. So I'm going to switch this to false. I'm going to comment out this operation, and now let's go ahead and plot this. And tell you what, instead of plotting a line, what I'm going to do is, I think I set this up so I can plot scatter plots. Yeah, so here, let's do this. So that way I can just plot each packet as a little dot. So let's go ahead and run this again. This is going to actually choke a little bit. This isn't the most super robust code, but what I'm interested in is this. Look at this. So this is all of these packets. Let me see if I can put this over kind of off to the side. Right? This is all of the packets in this log file that we acquired over this 2-hour period. And look at this. The majority of it, yes, is clustered around kind of the Pacific Northwest, Seattle-ish area. But look at this. This is awesome. So we were actually, kind of down here is where we were. But look we heard packets from all over. We heard packets from Victoria, from Aberdeen, Olympia, 50, 100, more than 100 miles away. And we were picking up these APRS packets. In fact, I don't know if this is just a spurious result or somebody's got their transmitter set up to the wrong frequency, the wrong lat long, but we picked up this packet way up here in northern Canada, so hundreds of miles away. So I don't know if this is atmospheric scattering and bouncing a packet, but long story short, we heard some packet that claimed it was from way up here. So again, that's pretty darn cool that This system with Direwolf is picking up all of that information from all those different locations, and we are hearing it and logging it here into the file. So this is, again, like I said, pretty darn exciting that you're able to get all of this information with a really simple setup and a little bit of code. So, yeah, this is probably a good spot to jump back to the board and let's summarize what we talked about today. All right, so there you have it, a pretty easy way to listen for APRS packets that are coming out over 144.39 megahertz and then get it from your radio into the computer and then have Direwolf do the decoding. Now, once we have that information on the computer, the world is kind of our oyster. We can do a lot of stuff with that info. So we saw that you could go and take all of that information and plot it in you know, quasi real time. You can also extract information and data that is embedded in those packets, like temperature, as we saw, and there's a whole lot of other stuff. For example, in one of our future videos, we're going to be taking a look at how we can plot that data in real time and look at all of the different stations that we're able to hear and plot that using some free open source software. So if that sounds like fun, I hope you'll join me at one of our future videos where we'll all learn something new together, hopefully. So with that being said, I think this is a great spot to leave it. I hope you enjoyed the video today, and if so, I also hope you'll consider subscribing to the channel. Surprisingly, if you just scroll a little ways down and click on that subscribe button, it really does help me continue making these videos. And remember, the new videos come out every Monday, so I hope I'll catch you then. Until that time, I think I'm going to sign off. Talk to you later. Bye.